Hello, and welcome to EECraft. Today's video will be a continuation of our exploration of Microbit V2 port pin mapping for Arduino IDE. This knowledge is essential for Arduino IDE users to develop sketches for the BBC Microbit boards. While this video will focus on the pin mapping for the Microbit version 2 boards, the same method can be applied to find the corresponding pin numbers for the version 1 board as well. If you haven't done so already, please watch the previous video posted on this channel. In that video, we explored the pin numbers defined in the Microbit core for Arduino. These pins allow access to the LED matrix, 2 push buttons, and the touch inputs, including the Microbit logo on the V2 board. In this video, we will cover the remaining port pins that are connected to the built-in features such as the microphone, buzzer, accelerometer, and magnetometer. We will also discuss the remaining port pins on the edge connector. Just a quick reminder that the Microbit pinout details for Arduino IDE will only work if you have the Nordic Semiconductor NRF5 board's Core by Sundeep Mystery installed. If you haven't installed this board support package yet, please refer to a video previously posted on this channel. You will find the necessary details in the description box. Before we dive into understanding the pin numbers required to program the Microbit's internal gadgets or external devices, let me show you where I found this information. To access the pin information, you can locate the variant.cpp file in the BBC Microbit V2 directory on GitHub. If you are proficient in C or C++ programming, you can extract the pin details from this file. However, in the video that follows, I will make this process simpler for you. The Microbit V2 board comes with more built-in gadgets than its predecessor. In addition to the standard features, the V2 board includes an analog MEMS microphone, a buzzer, and an accelerometer-cum-magnetometer with an embedded temperature sensor from ST Microelectronics. These onboard devices are extremely useful if you want to customize your board to play or move something in a specific way. Let's start with the microphone on the Microbit V2 board. It is a MEMS analog microphone that can detect sound. The microphone is made by ST Microelectronics, and you can learn more about it by searching for its part number. There are 2 signals connected to the NRF52 microcontroller on the board. To enable power supply to the microphone, set the output signal, run mic, high. The port pin number is 28. The mic in signal is the analog sound signal input, which can be read on the analog input pin A6. If you're not using the microphone and want to use the mic in signal as the digital input, use port pin number 29. Enabling the run mic signal will not only provide power to the microphone but also activate an LED, indicating that the microphone is on. It's important to note that the LED indicator is visible from the other side of the board where the microphone is mounted. Additionally, there is a hole located at the bottom of the microphone, which can be accessed from the other side of the PCB through the opening on the PCB that aligns with the hole. The Microbit V2 board includes a passive buzzer that can produce sound by receiving pulse signals. Pin number 27 is assigned to the port that drives the buzzer, and this should be specified in any Arduino sketches that use the buzzer. The next device on board is a system-in-package chip that contains multiple sensors. The chip comprises a 3-axis digital linear acceleration sensor, a 3-axis digital magnetic sensor, and an embedded temperature sensor. The controller can access both sensors using an I2C serial bus interface. It is important to note that the accelerometer and magnetometer have 2 different I2C addresses. The Arduino equivalent pin numbers of this internal I2C interface are also provided. We have now covered all the internal pins. To access the external pins, simply use the pin number on the edge connector. For those new to C++ programming, a library is necessary. Install this library to access the accelerometer and magnetometer chip or to drive the buzzer using the Arduino tone function. After installing the library, you can start using the example sketches that come with it. Take a look at the examples provided. They allow you to test the accelerometer, magnetometer, and embedded temperature sensor. You can also use the tone function to play melodies on the buzzer and test the light sensor with the LED matrix and Bluetooth radio. Let me show you one sketch example that displays magnetic north and heading using the magnetic sensor on board. Note that you need to install the Adafruit Microbit library for the sketch to work. This sketch collects data from the magnetometer every second, computes the heading, and presents it on the serial monitor. It also utilizes the accelerometer data to determine if the board is being held horizontally. If it is, then it displays magnetic north on the LED matrix display using 2 dots. However, if the horizontal position is lost, the matrix display will be cleared. You can view the magnetometer data on the serial monitor, along with the heading value. If the board is held horizontally, the magnetic needle points towards the north. Otherwise, the display is cleared. Let's try the next sketch, which reads the temperature from the accelerometer sensor and displays it on the LED matrix. It's a simple sketch. Note the libraries used in the sketch. After uploading the program, you can view the temperature on the LED matrix display. The same data is also printed on the serial monitor. You can test the buzzer by running the example sketch and adjusting it. The particular library does not support programming the microphone. Nonetheless, if you're interested, I have developed a sketch to create a clap meter that employs the microphone as a sound detector. You can pause the video to examine the code. The sketch reads the analog value on A6, which is the analog input coming from the microphone. There are sound levels defined in a separate header file. The LED dot matrix displays the level depending on the value of the analog signal proportional to the sound detected. Enjoyed the video? We'd love for you to join our community by subscribing. Your support will help us create even more amazing content for you to enjoy. Thank you for watching.